The industrial 9 to 5 model is a legacy operating system running on incompatible hardware. We treat human cognitive output as if it were a linear function. 8 hours of input equals 8 hours of output. This assumes your brain operates like a conveyor belt, consistent, mechanical, and tireless. But if we look at the biological specifications of the human nervous system, specifically the limitations of neurotransmitter production and waste clearance, the 8-hour workday isn't just inefficient, it is biologically impossible to sustain. The data indicates that attempting to flatten your energy output into a straight line creates a massive signal-to-noise ratio problem. You are paying a tax on your intelligence every single afternoon, and you likely don't even realize it because you have normalized the sensation of cognitive friction. Today, we are going to look at the engineering specs of the brain to understand why the standard workday fails and how to rewrite your schedule based on ultradian rhythms and glymphatic clearance rates. Before we dismantle the schedule, we need to agree on the metric. We are not optimizing for hours at desk. That is a vanity metric. We are optimizing for cognitive throughput, the amount of high-quality signal your brain can generate before thermal throttling kicks in. If you are interested in optimizing your neural hardware, rather than just applying more brute force willpower, make sure you are subscribed to the channel. We treat the mind as a system to be engineered, not a mystery to be accepted. Now, let's look at the primary constraint, the oscillation of your biological clock. The first bug in the system is the concept of steady focus. We are culturally conditioned to believe that a good worker sits down at 9 a.m. and remains mentally acute until lunch. If focus wavers, we label it as a discipline failure or a lack of motivation. This is the myth of linear output. It assumes that attention is a resource you can summon on command and hold indefinitely, provided you have enough coffee or grit. However, this view ignores the fundamental physics of biological systems. Nothing in nature runs in a straight line. Heart rates vary, hormones pulse, and neurons oscillate. Trying to force a straight line onto a wave-based system causes destructive interference. The relevant biological mechanism here is the ultradian rhythm. You are likely familiar with circadian rhythms, which govern the 24-hour cycle. Ultradian rhythms are shorter cycles that repeat multiple times within that day. Research dating back to Nathaniel Kleitman, a pioneer in sleep research, identified the basic rest activity cycle. This is a 90 to 120-minute wave that governs both sleep cycles and waking alertness. During the upward slope of this wave, your brain is primed for high-frequency beta wave activity, what we call focus. This is supported by optimal levels of glucose and oxygen metabolism. However, after approximately 90 minutes, the system hits a biological ceiling. The hardware cannot sustain that electrical intensity. The brain shifts gears. It effectively requests a reboot. Here is where the error occurs. When your system signals that the 90-minute cycle is ending, you feel fidgety. You lose focus. You might reach for your phone. Most people interpret this as boredom or procrastination. They respond by drinking caffeine or forcing themselves to stare harder at the screen. This is a critical mistake. You are not fighting boredom, you are fighting physiology. By overriding this downregulation signal, you push your system into a stress response. You trigger the sympathetic nervous system to release cortisol and adrenaline to compensate for the lack of neural energy. You are now running on stress hormones, not clean energy. This works for a short burst, but the quality of your output degrades rapidly. You are effectively overclocking a CPU without adequate cooling. The patch for this bug is to switch from a linear workflow to a pulse-based workflow. You need to align your work blocks with your ultradian peaks. The literature suggests a hard limit of 90 minutes for high-load cognitive tasks. Set a timer. When the 90 minutes are up, or when you feel that distinct physiological shift toward distraction, you must stop. Not pause, stop. You need to respect the trough of the wave. The goal is to capture 3 or 4 high-amplitude cycles per day. Data shows that 4 90-minute sprints yield significantly higher total output than 8 hours of semi-distracted grinding. You are looking for intensity, not duration. Manage the wave, don't flatten it. Let's move to the second major hardware limitation: waste management. There is a persistent myth that thinking is metabolically free. We assume that as long as we feed the body food, the brain can process information indefinitely without residue. We view the brain like a computer processor. It processes data, and when it's done, the data is gone. This is incorrect. The brain is biological tissue. Every electrical impulse involves the movement of ions and the consumption of ATP. This metabolic activity produces waste products, specifically proteins like beta amyloid and tau. The brain is not a clean digital processor. It is a biological engine that produces exhaust. The mechanism for clearing this exhaust is the glymphatic system. Unlike the rest of the body, the brain does not have a traditional lymphatic system. Instead, it relies on cerebrospinal fluid, or CSF, to wash through the brain tissue and flush out metabolic toxins. Research published in journals like Frontiers in Integrative Neuroscience highlights that this cleaning process is largely an offline function. It is most active during deep sleep, where the space between brain cells actually expands by up to 60% to allow CSF to flow through. However, recent studies suggest that low arousal states during the day also play a role in homeostasis. When you are in a high-focus, high norepinephrine state, these channels are constricted to prioritize rapid processing. You cannot effectively clean the machine while running it at maximum RPM. If you ignore this, you aren't just tired, you are toxic. As you push through hour 4 or 5 of continuous work without adequate downtime, metabolic waste accumulates in the interstitial space of the brain. This buildup physically impedes neural signaling. This is why complex decision-making becomes impossible in the late afternoon. It is why you read the same paragraph 3 times without absorbing it. You are trying to fire signals through a medium that is clogged with metabolic debris. The fog you feel isn't just a metaphor. It is the biological reality of a waste clearance backlog. Continuing to work in this state has a negative ROI. You create more errors than value. To mitigate this, the recovery phase of your ultradian cycle must be optimized for clearance. This does not mean scrolling social media. This is critical. Visual processing of a screen keeps the brain in a high alert, norepinephrine dominant state, which keeps the glymphatic channels constricted. The protocol requires a total disengagement from focal tasks. The most effective method is active recovery. Physical movement, specifically walking, increases blood flow and intracranial pressure dynamics that aid in fluid exchange. You need 20 minutes of non-focal, low stimulation time after every 90-minute sprint. Staring at a wall, walking outside, or closing your eyes. You are not taking a break. You are facilitating a waste clearance cycle to prepare the hardware for the next load. This brings us to the operational software: attention. The modern workplace operates on the assumption that we can run multiple applications simultaneously. We keep Slack open, email in the background, and a spreadsheet in the foreground. We believe we are multitasking. The myth is that the brain has multiple cores for conscious attention. It does not. The brain is a serial processor when it comes to high-level cognitive tasks. It can only attend to one semantic stream at a time. What feels like multitasking is actually rapid context switching, and this switching comes with a severe metabolic penalty. Every time you shift your attention from a report to a notification, your brain must save state on the current task, disengage, and load state for the new task. This is known as attention residue, a concept formalized by Sophie Leroy. The biology shows that when you switch tasks, a residue of your attention remains stuck on the original task. The recalibration process consumes glucose and time. Studies suggest it takes an average of 23 minutes to return to a state of deep flow after a disruption. If you are interrupted every 10 minutes, you are mathematically never in a state of peak performance. You are perpetually in a state of cognitive ramp-up, burning fuel just to switch gears, never actually reaching cruising velocity. This is where the standard 9-to-5 environment actively sabotages the biology we just discussed. Open offices and instant messaging platforms are designed for collaboration, but they are biologically hostile to deep work. They prioritize availability over capability. By demanding constant connectivity, the modern workplace forces your brain to stay in a state of continuous partial attention. You are essentially keeping the engine idling at high revs, but in neutral. This burns out the dopamine receptors and exhausts the prefrontal cortex without producing any significant work product. You feel exhausted at 5 p.m. not because you worked hard, but because you spent 8 hours fighting distractions. The protocol for fixing this is radical exclusion. During your 90-minute focus blocks, you must simulate a Faraday cage. No notifications, no phone, no email. You cannot rely on willpower to ignore a ping. The auditory or visual stimulus alone triggers an orientation reflex in the brainstem that breaks focus, even if you don't click it. You must eliminate the stimulus entirely. Batch your communication. Designate 2 30-minute windows per day for synchronous chaos, responding to emails, Slack, and calls. Outside those windows, you are offline. You treat your attention bandwidth as a secure facility. Nothing gets in without clearance. Finally, we must address the timing of these cycles. The 9-to-5 model assumes that 9 a.m., 1 p.m., and 4 p.m. are interchangeable units of time. It assumes that an hour is an hour, regardless of when it occurs. This is the flat time fallacy. From a biological perspective, an hour at 10 a.m. and an hour at 3 p.m. are fundamentally different currencies. Your neurochemistry fluctuates wildly across the day based on your circadian phenotype, or chronotype. Treating all hours as equal leads to poor allocation of resources. For the average phenotype, the day begins with a cortisol spike, the cortisol awakening response, which clears adenosine and primes the system for alertness. This creates a natural peak in cognitive analysis capabilities in the late morning. However, roughly 7 to 8 hours after waking, there is a systemic dip in circadian arousal. Core body temperature drops slightly, and cortisol levels taper off. This is the postprandial dip, often mistakenly blamed entirely on lunch, but it is actually a hard-coded circadian feature. Later in the day, there is often a second, smaller wind of recovery, but it lacks the analytical sharpness of the morning. Trying to do heavy analytical lifting during the circadian trough is like trying to drive a car with the parking brake on. The friction is too high. Most people try to push through this afternoon slump with sugar or caffeine. This is a strategic error. You are masking the signal, not fixing the energy deficit. By forcing high-focus work during a biological low point, you are getting the lowest return on investment for your effort. You are burning matchsticks to keep the lights on. The smart move, the move that looks lazy to the uneducated observer, is to throttle down. If you fight the biology, you extend the recovery time needed later. If you surrender to the rhythm, you can rebound for a second peak. The 9 to 5 demands consistency, but your body demands modulation. The protocol here is task mapping. You must audit your tasks and categorize them by cognitive load. High-load tasks, coding, writing, strategic planning, must be mapped to your peak cortisol windows, usually the morning blocks. Low-load tasks, meetings, emails, administrative maintenance, must be mapped to the troughs. Do not waste your peak energy on low-value tasks like checking email. That is a misallocation of resources. If you are in a slump, do not try to write the report. Clean your file system. Answer routine messages. Use the low-energy state for low-energy tasks. Align the difficulty of the work with the capacity of the hardware at that specific moment. When we combine these elements, the 9 to 5 dissolves. What replaces it is a system of 3 to 4 90-minute high-intensity sprints, separated by genuine active recovery. This structure respects the ultradian rhythm, allows for glymphatic clearance, and minimizes attention residue. It turns out that a sustainable workday looks less like a marathon and more like interval training. You push hard, you recover fully, and then you go again. This might result in only 5 or 6 hours of actual desk time, but the output of those hours will dwarf the output of 8 diluted, distracted hours. We are trading volume for density. The Industrial Revolution gave us the 8-hour day, but evolution gave us the 90-minute cycle. One is based on the needs of a factory, the other is based on the needs of a neuron. As knowledge workers, we are not paid to be present. We are paid to be effective. Effectiveness requires biological compatibility. You cannot negotiate with your biology. You can either optimize for it, or you can break yourself against it. The 9 to 5 is an arbitrary construct. Your physiology is a hard constraint. Design your workflow around the constraint. If you want to move deeper into system optimization, we are building a library of these protocols. Subscribe to the channel to get the data as we synthesize it. Stop trying to manage time. Start managing energy. Test the 90-minute protocol for 1 week. Collect the data on your own output. If the efficiency goes up, keep the patch. If not, revert. But stop running the legacy code. I'm Tom, and this is an analysis of the mind.